If I had to pick one unit that mattered for your freshman year, this is it, right? This is the one that it's not going to go away. You're going to do it your sophomore year, your junior year, your senior year. And if you go to college and you have to take any form of a math class, you're going to do it there too. So this is like the foundation of every single math course. Okay? You're going to learn how to factor, and that's really, really big in every single math course that you take. So if you haven't locked in, how you guys put it, so far this year, this is the unit you're going to want to do that, okay? So that it carries through the rest of the semesters that you'll use it, which you will use it. So your new toolkit and workbooks are purple. We're running out of colors here. But there are only 2 units left. So we'll do this one, and then we end with probability. All right, so here are your new workbooks. 1, 2, 3, 5. Just jot your names on these. All right, we're going to start in the toolkits today with section 1, which is naming polynomials. But before we can start to name polynomials, you need to know what that word actually means, right? Like, what is a polynomial? So the definition of a polynomial is here on the board, and so you're filling in the stuff that's in the blank. So a polynomial is an expression which is composed of variables, constants, and exponents that are combined using, you don't have to write mathematical operations, you can just say using plus, minus, times, divide, right? So using the math operations. So in your head, if you're picturing an equation, any equation in the world, that equation is considered a polynomial, okay? Polynomial is a fancy way of saying equation, because an equation is you like putting these things together, right? So a polynomial does that. The difference between an equation and a polynomial doesn't necessarily need the equal to sign, right? It can just be an expression. And most of the equations that you're thinking of are probably pretty basic, like a linear equation, right? A polynomial can get really complicated because it can have any exponent to it, any coefficient to it. So a polynomial could look a little more complicated than any equation you were picturing. All right, so here it says blank is an example of a polynomial of the monomials, which you'll know what that means, monomial soon, okay? So we've got 3x to the 4th power, 5x to the 2nd power, negative 7x, and 1. Right now, they're just all separate terms. If I want to make them a polynomial, all I have to do is put plus, minus, times, or divide between them. Typically, you're going to see plus and minus between them. It's pretty rare that you see divide. We will eventually, but I'm just going to do this one with something that you're more than likely going to see. So a polynomial for this could look like this. 3x to the 4th, and instead of a comma, plus 5x to the 2nd, and instead of a comma, minus 7x plus 1. Now it's all together rather than separated, right? This is called a polynomial. It's an expression, because there isn't an equal to sign. That would be an equation. So it's an expression that's composed of variables. We've got x. Constants, those are numbers without variables. We've got 1. Exponents, we've got a 4 and a 2. And I'm using plus and minus to separate them. Polynomial. Fancy word, really is just like an equation. All right? Anybody need more time with that definition? Okay, so like terms. Like terms are terms with the same base and exponent. So they have to have the same variable and the same exponent to be considered like terms. Bases are usually variables in these type of problems. So if you have two terms that have the same variable and the same exponent on them, you can combine them. And the way that you combine them is you keep the variable and the exponent part the same, right? The part they have in common doesn't change. You'll add and subtract their coefficients. So keep the base and exponent the same and add or subtract the coefficients. That concept can be confusing because we're coming off of a unit where we multiplied coefficients, we kept bases, we added exponents, we subtracted exponents, we multiplied exponents. In this unit, we're going to keep the exponents the same. And I will explain why in the example. The reason that I am not adding exponents or subtracting exponents or multiplying exponents is what separates these two things is a plus sign. If this was a times, then I would use the multiplication property of exponents, which says multiply the numbers in front, keep the base, add the exponents. All right? If this was like this and then there was like a power on the outside, I could multiply the exponents. But that's not what's happening here, right? This is just adding. And when we add exponents, we're just combining like terms. So in order for these two things to be like terms, they need to have the same variable, which they do, and the same exponent as well, which they do. So because those two things match, those are considered like terms. When you combine like terms, you keep the x squared part the same. All you do is combine the numbers in front. So I'm going to do 3 plus 5. So this is 8x squared. So this is like me saying I have 3x squareds, and I add 5 more in. They're all still x squareds. I just have more of them. I have a total of 8 of them. So combining these, I get 8x squared. Now if you look at the next term, we've got x to the third y, x to the third y. They match perfectly in terms of their variables and exponents. If this had like a 2 on it and that one didn't, now they're not like terms anymore. They have to be identical, okay? If they're identical though, which they are, you keep the variable and exponent part the same. That's not going to change. And then you subtract the coefficients because it's a minus. So this is like 4 minus 1. This is like I have x to the third y 4 times. And I take away one of them. Now I have x to the third y 3 times. So it's 3x to the third y. Everybody okay so far? All right, now in terms of like terms for the next pair, I'm going to combine this with this. And then separately, if I can get my highlighter to work, separately I'm going to combine those x's, right? Because they need to have not only the same variable, but they need to have the same exponent. And these don't have an exponent of 2. What is the exponent on the green terms? 1. So they both have an exponent of 1, which makes them have something in common. So when I'm combining like terms here, for the pink terms, I'll keep the x squared part the same. The base and the exponent stays the same. And then I'll add or subtract the coefficients. 4 minus 6 is negative 2. And for the green terms, I'll keep the x the same. The variable part stays the same. And then 4 minus 10. For the last one, I've got a 6x to the third. In order to have a like term with 6x to the third, I would need another x to the third, right? The variable and the exponent has to be the same. I don't have that, so I'm just going to leave the 6x to the third alone. And I'm just kind of going to go in descending order. So I worked with the exponent of 3. Now I'm looking at that exponent of 2. If I wanted to have a like term with this x to the 2, I would need another x to the 2. And I don't have that, so I'm just going to keep that the same. The only like terms I have here are just my regular x's. To combine them, I'll keep the x the same, and I'll do negative 7 plus 2, which is negative 5. You can totally write it in a different order, yes. What do we think? In order to combine like terms, the variable needs to match and the exponent needs to match perfectly. If it doesn't match perfectly, you can't do this. And if they match perfectly, then you're just adding and subtracting whatever numbers are in front of them. A lot of times I have kids want to tell me that this is 8x to the 4th, right? They want to add the exponents too. You only add the exponents if there's a multiplication symbol in the middle. If it's addition, you're just keeping them the same. Alright, so in your new workbook on page 3, you're going to do 6 through 11. Although it looks like I changed numbers 10 and 11. I don't know if that's reflected in your book or not. So if it's different than the ones in your book, just make that change. Alright, so these are the problems right after the beginning section, right? So there's like a 1, 2, 3, 4, 5. And then this is the next section. My 10 and 11 on the board don't match the 10 and 11 in your book. So just switch them up.
Oh, good.
It does?
There's two.
Oh, there's just parentheses. Yes. All right, so just cross off the parentheses. I mean, they don't make a difference, but just to keep it formatted the same. So 10 and 11 does match you. You just have parentheses. So there's 1, 2, 3, 4, 5, 6. I feel like 4 minutes is plenty. answers for these. Let me know if you have any questions before we move on here. So for the first one, I combined negative 6 and 11 to get positive 5, and then I kept the x to the 4 the same. So that's 5x to the 4th. For the second one, I did 2 minus 7, which is where I got the negative 5, and then I kept the x to the power of 2, the y to the power of 4 the same. You're not changing the variables, you're not changing the exponents. For number 8, I did 8 plus, there was no coefficient on this one, so I put a 1 and did 8 plus 1. That's where the 9's coming from. I kept the w squared x. Variable stays the same. 5 minus 13, negative 8. I kept the b, c to the 4th the same. For this one, I did 5 and 6 to get 11, and I kept the r to the 3rd the same. And then I did 8 and 3 for another 11, but they didn't have a variable on them, so I just kept that the same. And then this is like 1x minus 3x, so 1 minus 3, that's the negative 2, and the x stays the same. And then negative 2 and negative 5 is the negative 7. The order that you write this doesn't matter. So if you didn't write these bottom ones in this order, that's okay.
That's a plus 5 for any number level.
What is it?
Plus 5.
We changed it, right? Yeah, so I had made a note to change it. What do you think? Combining like terms. Easy? Hopefully? Alright, the second half of class here, we're going to work on naming polynomials. For now, I don't expect you to have any of this table memorized. It's going to look like a little overwhelming, alright? Eventually, by the end of the unit, you will have this stuff memorized. You're not going to be able to use the table for like a test or a quiz. Alright, but for right now, for the next few days, totally able to use it, alright? So there are a lot of different ways that you can name polynomials. You name polynomials based on two things. You name them based on their degree and their number of terms, okay? So, if a polynomial is degree 0, degree 0 means it doesn't have a variable, right? Because if it has a variable, then the let me backtrack. Degree means exponent, all right? So, when I'm saying name it on the degree, I'm saying name it on its highest exponent, right? So, you're looking at all the little numbers and picking the highest one, all right? If something has an x, but no exponent, there's like a 1 on that. If a problem doesn't have an x at all, that's what I mean by degree 0. So there's nothing I can even put an exponent on in terms of the variable. So this one, 6, is called a degree 0 because there's no variable at all in it, okay? So if you have something that is a degree 0, the name for that is called a constant. The reason it's called a constant is without a variable, it's never going to change. So if this was like a 6x, I could plug values of x in, and that 6 is going to change to another number. With no x there, the 6 is always going to be a 6. It's constant. It never changes. So that's why it's called a constant, all right? Number of terms is how many numbers are in the problem. For this 6, there's only one number in the problem. It's just the 6. And the polynomial name for a single term is monomial. Mono means 1. Io means it's a polynomial, right? So you just put the IAL at the end, and now it's the name for a polynomial. So, if I gave you the equation 6, it's called a constant monomial. Constant meaning there's no x's in this problem. Monomial meaning I'm only looking at a single number. So together, those two things make the name. All right? So for this next one, there is an x, so it's not a constant. The value of this equation is going to change as I change the value of x. So it's not a constant anymore. Anybody know what type of equation that is? It starts with an L. It's linear, okay? So, if the degree is 1, meaning there is an x in the problem, but there's no exponent on the x, we can put a 1, right? This is called degree 1. X exists, but there's no exponent on the x. That's a degree 1. We call those linear equations, which you already knew. Like an mx plus b. It's linear. Even without the plus b, it's still linear, right? Now, for this problem, there are 2 terms. There's the 5x and the 9. So for the number of terms, that's 2. And so we'll call this one a bi, because bi means 2. Nomial, because it's a polynomial. It's an equation. So 5x plus 9's fancy name, besides just calling it linear, is a linear binomial, because there's 2 terms in it. You can have a linear monomial. If the equation is just 5x and no y-intercept, it's linear still, but there's only 1 term, so it's a monomial. The degree of this next one, you're basing it on its highest exponent. So I've got an exponent of 2, an exponent of 1, and an exponent of 0. The highest exponent is 2. And if an equation's highest exponent is 2, we call those equations, anybody know what those equations are called? It starts with a Q. You might know it once you see it. It's called a quadratic, which is kind of annoying because quad is 4 and a quadratic is the power of 2. I don't know who made that, but those are called quadratics. So highest power is 2, we call that a quadratic. Now there are 1, 2, 3 terms here. 3 separate numbers. What do you think that's called? Trinomial. So we'll change the bi to a tri for 3, and now it's a nomial. So together, this equation is called a quadratic trinomial. Quadratic because of the 2, trinomial because of the 3 terms. The highest degree on this, the highest exponent on this is 3. Things to the power of 3 are called cubic. Again, doesn't really make sense because when I think of a cube, I think of 6, right? 6 sides of a cube, but a cubic is actually to the power of 3. Now, how many terms are in this statement? 1. So I'm going to go back to my 1 and say that this is called a monomial again. So if I'm graphing the line 2x to the 3rd power, I'm graphing a cubic monomial. Those 2 words come together. All right, so degree 4 is technically called a quartic. However, anything after 3, we're just going to call nth, whatever that number is, degree. So if you're looking at something that's highest exponent is 7, even though there is a name for that, we're just going to go 7th degree. There's a name for all of them, right? I'm not asking you to memorize 100 names. I'm asking you to know 4 of them. The first 4 you're going to practice. Anything after 3, you're just going to call the number and then the degree. Does that make sense? So if it was like x to the power of 6, you're going to call that a 6th degree. All right? And then 1, 2, 3. Let's add in a plus 1 there into your notes. Let's make this have 4 terms. And just like anything after 3, we're going to call by the degree. Anything after 3 terms, we're just going to call poly. Poly means multiple. So if you're looking at an equation that has 10 terms, we're going to call it a polynomial rather than give each of those numbers a name, like a pointer instead of doing that, we're just calling it polynomial after 3. So x to the 4th minus 2x to the 3rd plus 3x plus 1 is a 4th degree polynomial. Alright, so let's take a look at what we've got here. It says, write each polynomial in standard form. This is something we haven't done yet, okay? Standard form means that you're going to write the problem in descending order. So remember earlier when you asked me if the order mattered, and I said no. If the problem says it needs to be written in standard form, the answer is yes, the order matters, okay? It needs to go from highest degree to lowest degree. So highest exponent to lowest exponent. Starting with the highest exponent, ending with a constant, something that has no variable. That would be your last term, okay? Also in standard form, you have to combine anything that's a like term. Alright, so if you see two things that have an x in them, and they're just an x, you gotta combine them too. Alright, so standard form, descending order, combine like terms. So when I am looking at this first example here, I would not consider 3x and 4x squared to be like terms, because this has a power of 2 and this doesn't. So they're not like terms. I can't combine them. However, they're not in standard form because the highest exponent is 2. And in standard form, I write the highest exponent first. So in standard form, this is what it looks like. The order does matter. Highest degree goes first. Okay. Now that it's in standard form and I want to name it, I have to think of two things. What is the degree on that? What's the highest exponent? 2. So if the degree is 2, we call that a quadratic. So this is called a quadratic. All right, how many terms are there here? Also 2. So number of terms is 2. That's a binomial. So this is a quadratic binomial. I don't expect you to have that memorized. You're using the chart. All right, let's look at the next one. I want to write this in standard form. So I'm going to start with the highest exponent first. The highest exponent on letter B is 3, right? The 5x to the 3rd. So I'm going to write that first. The second highest exponent would be 2, but this problem doesn't have that, so I'm not going to write the 2. The next highest exponent would be 1, which is your linear terms, your x's. Now there are more than one of them, so I'm going to need to combine them. 4x plus 7x is 11x, so I'm going to write 11x here. In standard form, we're going to go from descending order and combine like terms when possible. And then at the very end is going to be my degree 0 term, my constant, which is the minus 1. The degree of this, the highest exponent is 3. So if you have something that is a degree 3, the highest exponent is 3, you call that cubic. And there are 1, 2, 3 terms in this. So if you have something that's 3 terms, you call it a trinomial. So this one is called a cubic trinomial. All right, and then the last one. I'm going highest degree first, lowest degree last, combining like terms when I can. So the highest exponent is 12x to the 4th, and then there's no x to the 3rd, which I would write next, and then there's an x to the 2nd, and then there's a 7. There was no like terms to be combined here because none of the variables and exponents matched. So the highest power here is a degree 4, which we just call 4th degree. So this is a 4th degree because of that 4 on the exponent. And there is 1, 2, 3 terms. That's a trinomial. So this is a 4th degree trinomial. Again, I don't expect you to have any of that memorized. I just want you to be able to read the chart for now. Alright? So last thing is I just want you to practice with some of those. So on practice page 3, the next group, which is 10 to 14, right after what we just did, you are going to write these in standard form, meaning I need you to have them in a certain order. Order matters. Highest degree is first, lowest degree is last. Combine like terms when you can, if you can. And then after you write it in standard form, you're going to use the chart to name it. So you can have the chart right next to it and then use that to name it. This is the last thing we're doing today. Alright, so for the first one, I didn't have any like terms to combine. I just had to reorder it to put it in standard form. So the squared came first, the linear came second, the constant came last. Quadratic, 1, 2, 3, trinomial. For number 11, I had two squared terms, so rather than write them separately, I combined them. 6 minus 13 is negative 7. I kept the x squared the same because when we combine like terms, you keep the variable, you keep the exponent. After my quadratic terms, I went with my linear and then my constant at the end. Highest power is 2, that's quadratic. 1, 2, 3 terms, that's trinomial. For number 12, my highest degree was actually the exponent of 7, right? That's the highest exponent, so I put that first. The second highest exponent was 3, and the third highest exponent was just the 1, the C. So I just had to reorder number 12. The highest degree is 7. We call that 7th degree. Anything after 3, we're just calling by its number. 7th degree. And then there's 1, 2, 3 terms, trinomial. For number 13, the highest power is 2. No like terms, so I just had to go in order. After 2, the next highest power is 1. That's the linear term, the 2x. And then the constant term at the end. Another quadratic because of the power of 2. 1, 2, 3, trinomial because of 3 terms. Number 14 was already in standard form. I didn't have to do anything. The linear term was first, the constant term was second. This is linear because the highest power here is 1, that's linear, and then 1, 2 terms is binomial. I don't think that you should have that memorized. I just want you to be able to use the chart for now. Alright? For homework tonight, there's a Canvas assignment because just like geometry, the only way you're going to learn those words is if you practice them, right? So it's just like here is an equation, and then for some of them it's saying what are the like terms, and then at the very end it's saying name it. Okay, if you are naming it, how many things should you be checking off? When you're naming a polynomial, you have to base it on its degree and its number of terms. So all of the questions that are asking you to name it, you need to be picking 2 boxes. Linear, binomial, 2 boxes. Quadratic, trinomial, 2 boxes. Make sure you're picking 2 boxes for those. If at the end it's saying that you don't have a 100%, but you're seeing a lot of green check marks, maybe one of your answers is right. Maybe you named the linear part right, but you named the binomial part wrong. So you could be getting parts of it wrong, all right? So you've got 3 attempts on that, and then I'll keep your highest score. Feel free to start that now. You've got 15 minutes. You should be able to get it done here in class.